Hi everyone, so this is our Chapter 5 review. I'm going to go over a couple things before we get started on this review, and those things are going to be with that yellow cheat sheet that we've been working on, just some of the important things that we need to remember as we're going through this. The first thing I'm going to talk about is when you do graph, you do need to pay attention to what you're multiplying by, that growth factor, so that you understand the shape of your graph. So if the numbers are getting bigger, as x's are getting bigger, your shape will look like this. And if you're multiplying by a fraction, then your numbers would be getting smaller, and so your shape would look like this. The other thing to keep in mind as you are graphing, and we did write this when we did our more graphing section, is this growth factor, that amount that you multiply, is never negative. If it looks negative, it's not negative. Chances are there's a y-intercept, which is when x is 0, that your y-intercept is negative. And it's probably a -1 if it looks like this is negative. And if your y-intercept is negative, what we learned about negatives hanging out in the front of our equations is that your shape is technically flipping. So your growth shape will look like this, and your decay shape will look like this. So it is important to try to get as many points graphed as you possibly can, so you can figure out what that shape's going to happen. All right? The other thing is to remember that negative exponents make fractions. So a lot of issues with negatives going on here. So negative exponents make fractions. What I tell my freshmen is that if you see the negative exponent, you move it. So you move the base, and then you lose it, meaning you lose the exponent. So you move it and you lose it. The other thing just to keep in mind is you do have these three formulas. You will be provided these formulas on the test, but you will have to know which formula to use where. So all of these formulas kind of consistently have the same thing. So when it's y equals, the y is your new amount. You're going to have b, and if you just flip b over, it looks like a p. Principal, beginning amount, all the same thing. You will have an r in every formula. That r will be given to you as a percent, but you will have to turn it into a decimal, so you can move that decimal 2 times to the left. You can divide by 100. You will have your time. And then in this particular formula, you will have an n, and n is how often they say something is compounded. So n is if they say compounded monthly, it's 12, weekly, it's 52, etc. And you'll have to know which formula to use by the vocab that's given to you in the problem. So if you don't see any mention of the word compound, you just use this very basic formula. But when you see compound and they give a specific time that they're compounding, again, these examples down here, you will use this one. And if you see compounding continuously, you use what we nickname the PERT formula. All right? And if by chance it does happen to be decreasing, that's where you use the minus sign. But here, since there is no plus or minus built in, your minus has to become a negative rate. So those are the big things to really think about as we go through this review. I'm sorry, a lot of bells here. And let's go ahead and get started. So this review will be broken down. I'm going to make the video into a couple parts. I'm going to make a graphing part, I'm going to make the solving part, and I'll make the formulas part where we see those word problems. All right? So I'm not necessarily going to do these problems in order. I'm going to do them from level of easiest to difficult. So I think the easiest one to tackle first is this problem 1b. And we're going to graph all of these with these x values. Okay? We might not fill in every y value for these x values, but that's how we're going to start. And we're going to start with our y-intercept, which is the beginning amount. That's that 2. And then this growth factor of 3 tells me what I should start to multiply by. So 2 times 3 is 6. 6 times 3 is 18. And if I'm multiplying by 3 this way, then I can divide by 3 this way. So 2 divided by 3 you could just write as a fraction. And if you take 2/3 and divide it by 3, that just makes it 2/9. And if you can't get the 2/9, then you don't worry about the 2/9. The only thing we haven't addressed in this graph is this 4, and 4 is our h value. So far, all the things we've graphed, our h is contained somewhere. They're in parentheses, they're in absolute value bars, they're no check mark. Here, h is contained in the exponents. So you always take the opposite of what you see. So I should be thinking -4, and that will tell me my points will be going left 4. So what I'm going to do is graph these points, the ones that I can graph, and move them left 4. So, what's this say? All right, so this one is actually going up to, I'm going to pause here. So on all of these graphs, it's going up to 15. It's a little hard to see. I think that's 15. So I'm going to leave this one out. So I'll graph 1, 6. So here is 1, 6. Let's turn the slide on a little better. So there's 1, 6. And I'm going to take this 1, 6, and I'm just going to move it left 4. And then I'm going to take 0, 2, and I'll move it left 4. And then -1 2/3, I'll just kind of estimate that one and move it left 4. And I think that's it. If you want to try to graph -2 2 9ths, 2 9ths, if you think about that, 9 9ths is worth 1. So 2 9ths is actually going to be a little closer to 0. That would put me very close to 0 and then moving it left 4. So just barely above that x-axis if you want to try to put that point. Before I connect those points, I remember starting out, every exponential graph has a y or horizontal asymptote at y equals 0. That wall can move, but moving left 4 doesn't change it. So I'm going to go ahead and put my horizontal asymptote in there. And then I'm going to connect the points. Try not to let it touch the wall or cross the wall. So from there, what I'm going to do is put these infinities with the arrows and then go here. So this arrow is going right and up, and this arrow is going left, and it's also going down, but as it works its way down, it does get stopped by the wall, which is at 0. So for my domain, my smallest x and my biggest x, I'm just going to actually write all real numbers. And for my range, when I do my smallest y, that's the 0, and my biggest y is infinity. And I don't want to include 0 on this because, remember, the shape can't touch the wall. So if it touches the wall, you're allowing it to include 0. So the parentheses are making sure I don't include 0. The end behavior, again, this favorite thing that we write. So when I write the infinity one, if x is infinity, my f of x or my y is also infinity. And then if I write the negative infinity version of it, then this time I'm going to put 0. So notice there's a big difference here. The range will affect one of your end behaviors for sure. All right, the next one I want to do is just the one below it. So I'm going to go ahead and make my table. Fill in these x values. And I'm going to identify my y-intercept first, which is 6. And then a half is what I should be multiplying by. And multiplying by half is the same as just dividing by 2, if that's easier for you. So 6 times a half, or 6 divided by 2, is 3. 3 times a half, or 3 divided by 2, is just 3 halves, which I'm going to write the decimal version. And if I'm dividing by 2 this way, then I'm multiplying by 2 this way, which will put me at 12 here and 24 here. So the other number that we're seeing is this -2, and that is an h value because it's contained in the exponent. So when I see this, I want to think +2, which is going to take all my points and go right 2. So the one thing I didn't talk about in the last graph is how do I know the shapes? Since the y's are going down, they're getting smaller, this should be the shape. And here, since the y's were getting bigger, I should have talked about that that was the shape. So I'm going to graph these points, as many as I can, and then we're going to connect them and answer the questions below. So -2, 24 is not going to fit, but -1, 12 will. -1, 12 is about here, right? And it's just going to go right 2 and end up right here. 0, 6 is also going to go right 2. 1, 3 will go right 2, and 2 and 1 1/2, I can estimate that, no problem, and that will go right 2. So let's talk about that wall. Again, every wall, every horizontal asymptote starts right on the x-axis, and moving it right to will still keep it on the right axis, or x-axis. So there's my wall, it doesn't move. And then I'm going to connect my points knowing that shape. So let's fill in these arrows. So this arrow is going left and up. Nothing's going to stop it going left, nothing's going to stop it going up. And this arrow is going right, and it is going down, but it will also get stopped by that wall of 0 like the other one. So now, the one I want you to really focus on is the range. What's my smallest y and my biggest y? I went ahead and put this in here just as a reminder of what this means. This is just saying if x is 2, what's your y value? And you can see that on your graph. If you go over to where x is 2, you'll see that you have a y value of 6. The end behavior. So when I use the infinity version, this time f of x is going to be working its way to 0. And when I do the negative infinity version of my end behavior, here it is, the y value is also going to 0. All right, let's start with, again, we're working our way from the easiest to the toughest. So the next one I want to talk about is this shape. So again, I'm going to go ahead and just start that table out. I'm going to identify my y-intercept, which is -2. And this says I should be multiplying by 4, so -2 times 4 is -8. -8 times 4 is -32. And if I'm multiplying by 4 this way, I'm dividing by 4 this way. So -2 divided by 4 is -2/4. That's just -1/2 if I simplify that fraction. And if I take this and divide it by 4, then that just becomes -1/8. But if that's too difficult, then you don't worry about it, because that would also be a very small number for us to graph. The other number that's hanging out there this time is this +2. This is not contained anywhere. So this is our k. So all the points I'm going to take will be moving up 2, and that does include the wall. The wall can move up and the wall can move down. So my wall is actually going to be right here now. And I want us to think about the shape. This is one of those things you have to watch out for. If we just looked at this as something we're multiplying by 4, then technically it should be getting bigger. But what's happening here is this shape, which normally should be doing this because we're multiplying by 4, that negative here is technically going to tell us that it should be flipping. And that's something you have to be really careful with, because if you don't get a lot of points on your graph, you really have to know the shape. So let's go ahead and graph. This won't fit on there, so I'm going to go to 1, -8, and then I'll move it up 2. So here is 1, and then there is -8, and I'll move it up 2. And 0, -2 will move up 2. -1 and 1/2, I'll go ahead and put that there. That will go up 2. And hopefully you can see how it's going like this and starting to curve in this direction, matching this shape. This point is a little difficult to graph, so I'm just going to not put it on there. And now we have this. So let's talk about this arrow first. It is going left, and it is going up, but this time it's going to get stopped by my wall, which is at 2. And this point is going right, or sorry, this arrow, and it's going down, and nothing's going to stop that. So as far as domain goes, if you haven't realized this yet, domain on every single graph is always all real numbers. Nothing's going to stop it moving left and right. What will stop it is something moving up versus down. So you're going to always see a number value on your range. So my smallest y and my biggest y. End behavior. So with the x and infinity version, right here, I can put -infinity for my y, which we're just writing as f of x. And when I write the negative infinity version of my end behavior, this time for my y, I'll put 2. Last graph. So if you are in the red cohort, we did change this to an E instead of the number that it was. If you're in the silver cohort, you got this corrected version. So let's go ahead and make this table. And my y-intercept, according to this, is -2. And let's remember what e is worth. E is worth about 2.7. There is a lot more to it, but we're just going to use 2.7. And multiplying by 2.7 could be easy. It just depends what we're starting with to multiply by. So -2 and 2.7, maybe that's a little too much. So what we can do is realize that it's about 3. It's not quite 3. So that's what I'm going to use. So when I take -2 and I multiply it by 3, I'm going to get -6, but I'm going to write -6-ish. It's not going to be quite -6 because this isn't quite 3. So this isn't quite -6. It's actually going to just be a little small. Well, not technically a negative smaller, but it's more like -5 something-ish. And then that's it. I think this is the only points I'm going to graph because, again, using these numbers isn't that easy. If you really want to, then you could take this times 3, and it's about -18-ish. You could divide this by 3 instead and make it -2/3-ish. Realize it's all around a ballpark number. But if you know the shape, you don't have to get all the points. So let's think about the shape. If you are technically supposed to be multiplying by 2.7, then again, what's happening, like in that last graph, is I should be seeing a shape that goes like this. But this negative out in front means my shape is actually flipping. So let's graph these points. Let's move them up 2 and think about that shape as we do that. So before I do that, I will remember that my wall can move up and down. So I'm going to go ahead and move it up 2 and put it right here. And now I'm just going to stick with these. So I'm going to go to 0 and -2 and move it up 2, and that's an exact point, like no problem at all. When I go to 1 and -6, it's not quite -6, it's really close, so I'll get close to -6, and then I'll just move it up 2, so it's not quite at -4 now. And so I only have 2 points, but because I know that shape, I'm good to go. That's all I need. And if you know the shape, this is the only point you really have to have on there. The y-intercept is good. All right, let's talk about the arrows. So this one is going left, and as it tries to go up, it will get stopped by our wall of 2. This one is going right, and it's going down. So again, I just put range because domain for every exponential graph is always all real numbers. So my smallest y is -infinity to my biggest y. If I look at f of 1 is about -3.7-ish, something like that. My asymptote, my wall, is now at this equation of y equals 2. Normally it's y equals 0, but now it's at y equals 2. All right. The last part I'm going to address is question number 2. And now we're going to do the exact opposite. If I give you the graph, can you write the equation? When this happens on the test, the only thing you're going to have to worry about is identifying the y-intercept and the growth factor. We will not be putting any shifts going left or right or up or down. So just identify the y-intercept, identify the growth factor, and you can put those things in there. So when we start with this graph, my y-intercept is right here, and that's a b value of 3. And then what might help you get the other values is to go ahead and just make that table and fill in as many values. Well, I don't think you even have to fill in as many values as you want. There's my y-intercept, and so what I want to do is to see what did they multiply 3 by to get to here, or go this way as well. So when I look at 3, which is here, I can't quite tell what that y value is. Or I'm sorry, not 3, at 1, I can't quite tell what that y value is. So I'm going to have to leave this one empty. But if I go to -1, I can see that this y value is 6. And then I would just look at, well, what do they multiply 6 by to make 3? Well, they're multiplying by half. They are dividing by 2, but we don't get to use dividing values for g. We can only use multiplying values. So dividing by 2 is the same as multiplying by half. And then I have my equation. So y equals my y-intercept of 3. In parentheses, I'll put the 1/2 with my x exponent. As far as the range goes, again, we're just trying to really hit this. I'm putting that a lot on there because that was a big mess up on the content check. So this arrow is going left and it's going up, and this arrow is going right, but as it goes down, it does get stopped by my wall. So my smallest y value and my biggest y value. All right, let's move to the next one. So here, again, I just need to identify my y-intercept, which is right there. That's a 4. And then, to help me figure out g, I'm going to make my table and see what values I can fill in, like the -1 or the 1. So there's 4. And if I go to 1, that is actually 8. And for me, I can see to go from 4 to 8, I'm just multiplying by 2. So that's my g value. So as far as the equation goes, I'll just put it here. It goes y equals my y-intercept. In parentheses, I'll put the 2. I don't technically need the parentheses. If you were to put this in your graphing calculator, you would want the parentheses. And then x as an exponent. My end behavior, that means I'm going to have to identify these arrows again. This one's going right. It's going up. This one is going left. And it's going down. But when it tries to go down, it gets stopped at 0. So end behavior, here goes the infinity version. And when I have the infinity version, f of x or y is going to infinity. And when I write my negative infinity version, as I hit f of x, it is going towards 0, not an infinity of any type. All right, one more. Here we go. So let's go ahead and make that table. My y-intercept I can see is 2. And then when I look at 1, I can't figure out what that value is. Not with 100% certainty. But when I go to -1, I can see that that is a 6 there. So how do they go from 2, sorry, not put in the wrong spot, here. So how do they go from 6 to 2? They are technically dividing by 3, but remember g has to be a multiplying amount, and dividing by 3 is the same as multiplying by a third. So I have my equation, y equals my y-intercept, and then 1/3 to the x power. Here goes end behavior, so this one's going left and up. This one's going right and down, but it will get stopped at that wall of 0. So here's my end behavior. When I do the infinity version, f of x is going to 0. And when I do the negative infinity version, when I do the negative infinity version, then my y or f of x is going to infinity. So that is our graphing part. The next video is going to be covering the solving, and just a reminder, this is a no graphing calculator portion.